All right, welcome. In this video, we're going to be practicing our exponent rules and working through Algebra 2 Homework 5.1. So let's just get to it. So the first one, it's looking like we're looking at dividing powers. Okay, so if we have, same base exponents and we're dividing, then that's what we're going to subtract the exponents. But just to remind you of why that's true, I'm probably not going to do this on all of them. I can just write out the 4s, 7 of them. 4, 5, 6, 7 copies of 4. Divided by 4 to the 4th would be 4 copies of 4. Oh, whoops, I got it wrong. So we can kind of cancel them off. 4 divided by 4 is 1. 4 divided by 4 is 1. We just keep doing that. Then we're left with 3 copies of 4 on top. So this is going to be equal to 4 to the 3rd. But you see, we could have done that also by taking 4 to the 7 minus 4 is 4 to the 3. Okay. And then this one, okay, we got the same base because we got -3 on both with parentheses. So, I would subtract the exponents. So it's -3 to the 3rd. And I guess 4 to the 3rd, I think that's a safe place to stop, but maybe you want to take it all the way to be just like a regular number, and that would be 64. Right, -3 to the 3rd power. Okay, well, a negative to an odd power is going to remain negative, right? Because it's -1 times -1 times -1. And then we would have 3 copies of 3. So this is, we could also, I don't know how you want to look at this, but this is like -1 times 3 to the 3rd power. And then, both of these are going to get hit with the 3rd power. So that's -1 to the 3rd times 3 to the 3rd. -1 to the 3rd. Okay, well, -1 to the 2 is 2 -1s, would be +1. And so this will be negative of 27. Okay. Over here we're multiplying powers. Okay, so we've got the same base, and we're multiplying, so that's where we're going to add the exponents. So that's going to be -8 to the 6th power. Now, I don't know what 8 to the 6th power is because, that's 2 to the 18th, and I don't know the numbers that high. So what I'm going to say is that, the negative to the 6th power is going to be positive because a negative to an even power, that's going to come back positive. And so I'm just going to say that's 8 to the 6th because I don't know what that number is. If you want to pull out a calculator or go to Google or whatever and figure out what that number is, you can do that. Okay, I'm just not going to here. All right, 7 to the -4 times 7 to the 4. Okay, that's where we're going to add the exponents. -4 plus 4 is 0. And we also know that 7 to the 0 or anything to the 0 is going to be 1. Okay. If you're like, wait a second, why is that true? Why is anything to the 0 equal 1? Why isn't that 0? Okay, well, 7 to the -4, that's 1 over 7 to the 4th. And then we're multiplying by 7 to the 4th, which we could call 7 to the 4th over 1. And then we're just going to have the same number on top and bottom. And that's why the 0 power is 1. So it's just that from a different perspective. All right. Now, h cubed to the 4th power. This is going to be where we'll multiply exponents, but I'm going to try to kind of remind you of why that's true. So I'm going to write out 4 copies of h cubed. Not plus, that's supposed to be times. Hold on. Pardon me. Okay, so then we had 4 of these h cubes. Again, if I added all these exponents together, because, I'm multiplying with the same base, and I could say 3 plus 3 plus 3 plus 3. Well, that's the same thing as 3 times 4. So that's going to equal h to the 12. If I was really desperate and really not understanding what was going on, I suppose I could write out 3 copies of h 4 times, and then you'd see that there would be 12 total copies of h. Okay. T to the -2 to the 6, I think the best way to go here is to multiply the exponents. So that would be t to the -12. And then I'm going to simplify it so it doesn't have any negative exponents. I'm going to remind you that's 1 over t to the +12 power. P to the 6 cubed, we're going to multiply those exponents, and that's just going to be p to the 18 power, because 6 times 3 is 18. Q to the -4 to the 5th power. Maybe I'll do it differently from how I did this one up here, and I'll leave that one in sight so you can contrast what I'm doing here. Q to the -4, wait, that's 1 over q to the 4. We're going to take that to the 5th power, and if I wrote that out 5 times, I'd have 5 copies of q to the 4 in the denominator, and I would add all those exponents together, and I get 20 total q's in the denominator. Okay, so 1 over q to the 20. Okay. 5 to the 3 times 5 to the -7. Okay, back to multiplying with the same base, so we're going to add the exponents. So that's 5 to the 3 minus 7. 5 to the -4. I know what 5 to the 4 is. I think 5 to the 2 is 25, and 25 times 25 is $6.25. I know 25 quarters is $6.25. Okay, so this is going to be, all right, the negative, okay, that's going to be 1 over 5 to the 4th power, and I just convinced myself that that was 625, so that'll be 1 over 625 because of the negative exponent. Okay. Negative 4 times negative 4 to the negative 2. There's a number of ways I could go here. I'm just trying to think about what y'all would be most likely to do with something like this. I think that y'all would deal with the negative exponent first, and then we'll try to just simplify based on that. All right, so negative 4 times negative 4 to the negative 2, well, that's 1 over negative 4 to the positive 2. And if I square negative 4, I'm going to get positive 16. And if I'm multiplying two fractions, it might be good to make that one divided by 1. And that's positive 1 over 16, and that's going to be negative 1 over 4. I see at least one other way to approach this one. We could have called that negative 4 with parentheses around it to the first power, and then added the powers together. That's probably the way to go. But I'm sure there's others. If you think of a slicker way to explain this one than I just did, why don't you tell me about that tomorrow? That would be really nice. I'd appreciate that. Okay, so x to the 7 over x to the 4 times x to the 2. Maybe because, we've got this fraction multiplied by this thing, maybe I'll deal with the fraction first, but it doesn't really matter. So I'm going to say x to the 7 divided by x to the 4, that's x to the 7 minus 4. Okay, so that's x to the 3 times x to the 2. And if I got 3 over here, 2 over here, are going to combine and make 5 total powers because we've got the same base, different exponent multiplying. We're going to add the exponents. Okay, and then this one, kind of the same thing. Maybe I'll deal with the numerator, the fraction first, and then deal with the fact that it's a fraction. So v to the 5 times v to the 3, that's going to be a total of 8 powers of v. We're going to add those exponents. So that's v to the 8 divided by v to the 2. And, okay, there's 2 down here and 8 up there, so I could cancel off 2 from top and bottom, and I'd be left with 6 on top. Or I could think about it with the subtraction property, where we're dividing two exponential things that have the same base. We can subtract the exponents. So it's going to be v to the 6th. All right, number 13. Negative 8t squared to the 3rd power. Well, that's like a negative 1 times 8 times t to the 2, and we're cubing that. So that's going to equal negative 1 to the 3rd times 8 to the 3rd times t squared to the 3rd. And is this 8 to the 3rd? No, 8 to the 6th. Okay, so 8 to the 3rd I probably should be able to do. Yeah, and I'll even show you how you could do this with the exponent rules that we already know. Okay, negative 1 to the 3rd is negative 1. Maybe let's do that. 8 to the 3rd, well, 8 is 2 to the 3 power. And we could say, okay, that's going to be 2 to the 9. Okay, and then this will be t to the 6th. Okay, 2 to the 9. I'm going to do some finger counting. Okay, 2, 4, 8, 16, 32, 64, 128, 256, 512. Okay, so 9 copies of 2 is 512. So that's negative 512 t to the 6th. It's kind of at the boundaries of our arithmetic skills, but I know the arithmetic they expect you to know is up to 2 to the 10th. Powers of 2, up to 2 to the 10th. So it's almost there. It's kind of closing in on it. All right, so this other one, negative q to the 4 over 5 to the negative 3rd power. I think the first thing I'm going to do is I'm going to deal with the fact that it's a negative exponent. Okay, because if it's, x to the negative 1, that's 1 over x. If I've got a fraction to a negative power, it's going to flip the fraction and remain the positive power. So I'm going to say, all right, this is, and I'm just going to choose for the negative to go with a 5. Okay, so I don't get it confused with the even exponent and think it's just going to go away magically or something. It's not. So if I flip this, I would get negative 5 over q to the 4. I'm going to take that to the positive 3rd power. All right, if I take negative 5 to the 3rd power, that would be negative 5 times negative 5 is positive 25. And I multiply by negative 5 again, I get negative 125. And then if I multiplied q to the 4 times q to the 4 times q to the 4 in the denominator, well, that would be 3 copies of q to the 4, or 12 total copies of q if you list them all out. So it would be negative 125 over q to the 12. And then over here, I think I'm going to do the same thing. I'm going to deal with the fact that this is a negative exponent first. Remember, negative exponents flip fractions. So this is going to become 3h to the 5 over 1 to the positive 4 power. 3 to the, okay, so I need to, take all of this stuff to the 4th. So it's going to be 3 to the 4, h to the 5 to the 4, divided by 1 to the 4. Okay. And so that's going to be h to the 20, right? We're going to multiply those exponents here. 3 to the 4 is 3 times 3 times 3 times 3, so it would be 9 times 9 is 81. So that's 81 h to the 20th power, because any power of 1 is going to be 1. Any real number power of 1 is going to be 1. And so we don't need to divide by 1. Not doing anything. Right. So now we're going to simplify the expression and write our answer using only positive exponents. Okay, we can do that. Okay, the negative exponents are coming in over here. So if I take negative 2y to the 5th power, okay, maybe you've seen me distributing these exponents over multiplication, but like, I don't know, why can you do that? I'm proposing that this is negative 2 to the 5th times y to the 5th. Maybe you don't believe me. Okay, that's where I'll show you over here in red. So that's negative 2y 5 times. Okay, and this is, multiplication, if we have 4 times 5 times 19, that'd be the same as 4 times 19 times 5, if you think about it. It doesn't really matter what order we multiply stuff in. So I could collect all the negative 2's together and all the y's together, and that's where I'd say, all right, in terms of negative 2, okay, I've got 5 of them, 1, 2, 3, 4, 5, okay, they're all here, and then 5 total copies of y, okay, that's y to the 5th. Okay, now, if I have 5 copies of negative 1, that'll end up being negative, because an odd number of negatives makes a negative. And so I'll have negative 2 to the 5 is going to be 32. 2, 4, 8, 16, 32. And then I'll just have 5 powers of y. All right, I think the first thing I'm going to do is deal with this negative exponent. So it's going to make this a fraction, 1 over 3d to the 3rd power. Okay, and so the 3 will get cubed, and so will the d. So that's going to be 1 over 3 to the 3 is 27 d cubed. Okay, and then 5 over b to the negative 3rd power, I'm going to flip this to deal with the negativity in the exponent. So that's b divided by 5 to the 3rd power. Okay, so I'm going to take b to the 3rd power and 5 to the 3rd power, because I'm multiplying b over 5 times b over 5 times b over 5, right? So I've got 3 copies of b and 3 copies of 5 to the 3rd, that's 125. Okay, because 5 times 5 is 25, and 5 quarters is $1.25. All right. Okay, here we go. I was kind of expecting these, wondering where they were, when were they going to show up. Okay, so what we got to do is, I think, just kind of start from the outside and work your way in, and just keep simplifying and just make sure you're doing everything right. So if I've got a bunch of stuff multiplied together to an exponent, that exponent goes to everything. So I've got 3 to the 3rd, x squared to the 3rd, y to the negative 3 to the 3rd, divided by 2 to the 3rd, x to the negative 3 to the 3rd, and y squared to the 3rd. And now I'm just like dealing with it. I'll get rid of that negative exponents eventually. So that's going to be 3 to the 3rd is 27. X squared cubed, I multiply the exponents. Y to the negative 3 cubed. And divided by 8. X to the negative 9. Y to the 6th. And maybe I'll deal with the negative exponents now, right? Now you could just be like, wait a second, x to the 6th, x to the negative 9, that's going to be x to the 6 minus negative 9 will be x to the 15. great. If you see it that way, you do it that way. Okay, but maybe you don't. Maybe you're like me and you want to deal with negative exponents by sending them to the other side of the fraction, because that's one of the big themes of this course, right? It's negative exponents and fraction exponents. And we're only talking about negative exponents right now, but we'll get there with fraction exponents. So I've got 27x to the 6, x to the 9, divided by 8y to the 6th, and then the y to the negative 9 comes into the denominator and becomes y to the positive 9. Okay, and now I'm going to combine these x's that have the same base, right? And I can add the exponents. So that's 27x to the 15, like I was saying earlier, divided by 8y to the 15. Yeah. Okay, and then this one. All right, now if, okay, I got negative 6 to the 4th power. Am I supposed to know that? 36 times 36? I don't think so. I don't have that. Maybe you've got that, and if you do, maybe you should, join up with Number Sense. I'm looking for participants for that for UIL Mathematics this year. If you're really good at arithmetic, I need you to talk to me because I could use you. All right, but a to the negative 9 to the 4th. Okay, these numbers are just out of control. B to the 5 to the 4 divided by 2 to the 4. I know that. That's 16. A to the 2 to the 4. And b to the negative 4 to the 4. Okay, I'm concerned I'm going to run out of room here, but that's probably my own fault. So that's going to be the positive of 6 to the 4. A to the negative 9 times 4 is a to the negative 36. B to the 5 times 4 is b to the 20. Divided by 2 to the 4 is 8. Well, I actually think I will be able to simplify this if I think about it numerically after the fact, but I'm just going to try to get all the exponents right first. B to the negative 4 times 4 would be b to the negative 16. Right? 2 times 4, 8. 4 times 4 is 16. Yeah. All right. And then I'm going to say, all right, a to the negative 36 minus 8 more would be a to the negative 44 power. So that's going to become a to the 44 in the denominator. B to the 20 minus negative 16, that would be to the 20 plus 16 is b to the 36. It's just going to be an issue of me figuring out what this number is. But 8 is 2 times 2 times 2. And I know that each copy of 6 has a factor of 2 in it. So I should be able to cancel some stuff off. All right, so I'm going to go up to the side. I'm going to get a Post-it note. And I'm going to go over here. And all right, 6 to the 4 is 6 times 6 times 6 times 6. Okay. Divided by 8 is 2 times 2 times 2. So I'm going to just simplify. 6 divided by 2 is 3. 6 divided by 2 is another 3. And then I'm going to get another 3. All right. So I've got 3 times 3 times 3 is 27 times 6. Okay. So this equals 27 times 6. Okay. I know what 27 times 3 is. That's 81. So... Okay, so I'm going to group these over here, and I'm going to say that's 81 times 2 is 162. Okay, and maybe you're like, okay, I'd rather just leave it at 6 to the 4 over 8, and I think that's probably all right. This is not an arithmetic class, this is an algebra class. And although arithmetic is important, it's not the most important thing. What's really important right now is your ability to do the exponent rules, right? Not your ability to calculate 6 to the 4 divided by 8. If it was such a big deal, we'd be doing that type of thing every day. Okay, so now, whew, man. Okay, just 2 more of these. These are not, I wouldn't say these are my favorite type of algebra problem ever. And I don't know, maybe they are your favorite type, and no disrespect. We're going to give everything double its exponent. So 5 to the 2 is 25. X to the negative 4 times 2 would be x to the negative 8. Y to the 3 times 2. Divided by 2x to the, 2 to the 2. See, that's kind of the risk there when you try to skip some steps and just like actually do all of these. X squared is going to be x to the 4. And y to the 0 is 1, and 1 squared, oh, it's just 1. So I'm not even going to write that down. Okay, times 4 squared is 16, x to the 2, y to the 2, divided by y to the 3 squared would be y to the 6th. All right, and now I think it's time for us to just start combining things. Oh, 25 times 16, we can do that, right? Because 25 times 4 is 100, and 16 is 4 times 4. So I'm going to take 25 times 4. Oh, I'm dividing by 4 anyway, so I'm just going to do that. It was going to become 400 divided by 4, which is 100, but it's way easier to simplify first and say, 25 times 4. We know what that is. That's 100. Okay, now I'm going to say x to the negative 8 times x to the 2 is x to the negative 6. Y to the 6 times y to the 2 is y to the 8th. Divided by x to the 4 and y to the 6th. Now at this point, you could say x to the negative 6 minus 4 would be x to the negative 10, would become 10 copies in the denominator, or you could send it to the other side and say that the exponent is going to become positive, and x to the 6 times x to the 4 is x to the 10 in the denominator. However you want it, doesn't really matter. Okay, so that's going to be x to the 10 in the denominator, y to the 8 minus 6 is y to the 2, and then the 100 here. Okay, so I've got 100y squared divided by x to the 10. And then these. All right, anything to the 0 power is 1, so I'm just going to ignore that and forget it. 2 to the 4 is 2 times 2 times 2 times 2. That's going to be 16. B to the negative 16 times a to the 9, b to the negative 6, divided by b to the 3 to the 4 would be b to the 12. Okay, 3 to the 3rd is 27. B to the 4 to the 3 would be b to the 12. A to the negative 4 to the 3rd would be a to the negative 12. This is a lot going on here. Okay, so I'm going to put the numbers together. 16 and 27, yeah, those have no common factor. Okay, then I'll put the a right here, a to the 9. B to the negative 16, B to the negative 6, I think that would combine to be B to the negative 22, divided by 27, and A to the negative 12, and 2. So let me make sure that's legitimate. Yeah, okay. That was not like a copying error or anything. So I'm going to combine these B's and those B's. Okay, A to the 9. B to the negative 22 divided by 27, a to the negative 12, b to the 24. Okay. I think this time I'm just going to send the negative exponents to the opposite side of the fraction, right? Okay, this one's going to go up top, that one's going to go down below. So I'll have 16 a to the 9 times a to the 12 divided by 27 b to the 22 times b to the 24, which would be in total 16a to the 21. I'm going to add those exponents, add these exponents. We'll have 27b to the 46th power. Wow, that's a lot. But find x and y. Oh, good. Okay, I'm glad we had one of these on the homework. Okay, because I'm pretty sure I put one of these on the quiz. And I believe, yeah, this is gonna give us a system of 2 equations and 2 variables, which, you know, we always need to practice. So I'm going to combine these using our exponent property, that when we have 2 things with the same base and we're multiplying them together, we're going to add the exponents. So I'm going to say this is going to be b to the x plus y equals b to the 8. Okay, well, that means that x plus y needs to equal 8, right? That's not unreasonable. Okay, so I'm going to write that off to the side. It's my first equation, x plus y equals 8. Right, and then b to the 4x times b to the negative 2y, well, we could combine those, again, with addition, because this is, you know, that's our exponent property. 4x minus 2y equals b to the 2. So that means 4x minus 2y has to equal 2. Okay, now I'm going to solve this system with substitution or elimination. And so I think I want to eliminate on y. Yeah, this is set up perfectly. So I'm going to go maybe off to the side over here. So 2x plus 2y equals 16. Got to double everything. And then I'll leave that one the same. 4x minus 2y equals 2. Add that all together. I'll get 6x equals 18. That means x needs to equal 3. And then up here, x plus y equals 8. That must mean y equals 5. Okay, and I don't think I need to explain since I showed all of this work that led to my answer. I think that's my explanation. You know, solve the system. Okay, I used exponent properties. I don't need you to narrate that process to me. All right. Now, here's something that I think this came from one of these like workshops where you had a bunch of teachers in the room and talking about teaching algebra. But I really liked this set of problems, and I think it's a different take on what we're doing right now. So you're going to look at this, and this is like a worksheet that a student has missed every question on, and so you need to give them for each error, correct it, and then write an explanation, of why. Okay, now my explanation might just be like regurgitating the rule, because sometimes that is the best explanation. And you don't need to explain to me why the exponent rules are what they are. That's not going to be necessary here. Okay, so 3 to the 2 times 3 to the 5 equals 3 to the 10. Okay, they mistakenly multiplied their exponents, but we know that when we're multiplying two things with the same base, that's where we're going to add the exponents. So I'm going to say it's equal to 3 to the 2 plus 5, which is equal to 3 to the 7. And I'm going to say that, remember, x to the a times x to the b equals x to the a plus b. But maybe your explanation was you wrote out 3 times 3 times 3 times 3 times 3 times 3 times 3, and that's 7 total 3. A perfectly fine explanation as well. All right, x to the 0 times x to the 2 equals x to the 0. No, again, you're making the same error, man. Like stop. Please start adding these exponents together. So this is equal to x to the 0 plus 2, which is x to the 2. Okay, that's another piece of evidence why anything to the 0 is 1, right? Because this should come back to x to the 2. 1 times x to the 2, well, that'd be x to the 2. I might just say x to the 0 is just 1. Because I don't think it would be helpful feedback for the student to get that same thing again. Be like, again, I'm going to tell you x to the a times x to the b equals x to the a plus b. The student's reading the feedback. They already got that. Okay, so a to the 1/3 times a to the 3rd equals a. It's like, man, we're going to add the exponents. Equals a to the 1/3 plus 3. That doesn't look right. And yeah, 1/3 plus 3 up here. 3 and a third, that's 10/3. So that's a to the 10 divided by 3. And I know we're not talking about fraction exponents yet, but you see what they're doing. They're multiplying the exponents. They should be adding them. We can add two fractions. Okay. I think my explanation is you're multiplying exponents. And that only happens when we're taking power of a power. Okay, that's what I'm going to say there. Okay, so b to the -4, or b to the 4 to the -2 is b to the -6. No, you need to multiply the exponents here. So this is going to equal b to the -4 times 2, which is b to the -8. Okay, and I guess since it's the first instance of this error occurring, power of a power, I'm just going to give them the rule. X to the a to the b equals x to the a times b. And then, oh, hey, here we got something different. We divided 8 by -4. Okay, that's interesting. Okay, I might say, okay, that's supposed to be a to the -4 times 8, which would be a to the -32 equals 1 over a to the 32, if you had to go that far. And then my explanation on that would probably be, maybe I'll switch up what I'm saying here and just say the same thing a different way. Power of a power, okay, we're going to multiply the exponents. All right, x to the negative 2 to the 1/2 times x to the negative 1 equals x to the 0. I'm not sure what would, negative 1 times negative 1, I don't know. It barely even looks like a negative 1, I just know it's there. I'm not sure how you made this error. It's all right. We're going to multiply the exponents. X to the negative 2 times 1/2 is negative 1 times x to the negative 1. We need to add those exponents. Okay. And it's again add exponents. When you're multiplying things with the same base, we're going to add those exponents. All right, negative x minus 1. Okay, that would be where we had multiplied the exponents, and I would say we multiply the exponents when taking power of a power. Okay, that would be how you get 2 to the, oh no, I don't know. That would be when you would multiply the exponents. I'm not saying that's equivalent to what that is, but that's a multiply the exponents type scenario. All right, so correcting the error is we're going to add the exponents together. So 2 to the x plus 1 minus 1, 2 to the x. Okay. And over here, x to the 5 divided by x to the 5 equals x to the 1. Okay, we know anything divided by itself is 1. Okay, so first of all, that's just equal to 1. Okay. 0 divided by 0, that's not equal to 1, but we're not going to talk about that in this class. At least not yet. Maybe way later, maybe towards the end when we talk about rational functions, when we talk about functions like 1 over x and things like that, we might talk about 0 over 0 a little bit. But it's a very pre-calculus and calculus topic. So another way we could say, or x to the 5 minus 5, which equals x to the 0. Okay, remember that x to the a divided by x to the b is x to the a minus b. Okay. A to the 2 divided by a to the 4 is going to be a to the 2 minus 4. So maybe I'm just going to assume that like a better thing would have been like negative of a to the 2. And you could have been like, hey, negative exponents don't make a negative number. That's something that's not an error I've seen on this thing. Okay, but what kind of feedback? It's the same here. I guess subtract when dividing. So when dividing with the same base, we're going to subtract exponents. And then the last one, x to the negative 6 divided by x to the negative 2 is x to the 3. That would be where they have divided the exponents. I can see why they would want to do that. Okay, but we need to subtract the exponents. Again, the same advice here. So this is going to be x to the negative 6 minus negative 2 is x to the negative 4 is 1 over x to the 4. If you are all out of explanations to give, then, I think we could probably do without on that one. All right. Josh and Caleb were working on the homework. Josh said 2 to the 3 times 2 to the 3rd equals 2 to the 5, or 8 times 4 equals 32. That seems reasonable to me. Okay. Caleb said that the problem is the same as 2 to the 3 squared, which is 64. Okay, Josh is correct. He followed all the algebra rules. I think the only way that you could really justify your answer is by talking about why Caleb is incorrect. Okay, 2 to the 3rd squared, that equals 2 to the 3rd multiplied by itself, right? So it would be 2 to the 3rd, 2 to the 3rd, but that's not what we were talking about up here. Okay, so that's what I would say. This statement here is not untrue. 2 to the 3rd squared is 8 squared, which is 64. It's just not the same question as we had up there. Okay, maybe believe the best in Caleb. Think he just made a copy here. He just copied the problem down. Maybe. Okay, I think that's going to be all. Yeah, okay, that's going to be all. That was a good set of problems for us to practice our exponent properties. Thanks for watching. I hope this helped.